morning. I'm Phil Jackman from Sun Chemical. I've been in print for 24 years, the first half in security printing, so the last 12 years I've been very much embedded in the world of inkjet. So I want to talk about digital print for manufacturing, and certainly under all the titles here today, Sun Chemical could have talked about any of the topics. We've got a strategic investment and sizable business in labels and packaging, and certainly have solutions for all areas of packaging, whether that's inkjet, ink primers, and overprint varnishes for more complicated things like flexible packaging, but also labels, carton board, etc. But also some of the industrial topics. We've got a business in textiles, we've got activity in decor, flooring, and even some more exotic things like printable electronics. But given 15 minutes on manufacturing, I want to talk about something, or a couple of case studies at least, on sort of how inkjet can do something different. A lot of the time in the world of inkjet, we're challenged to make something the same. So I've got this analog product, and I want to make the same thing, but digitally printed this time. However, it's got to look the same, act the same, smell the same, feel the same. It's got to be the same product. So any benefits of this all in the supply chain? It's about making things lean. That is a great solution, and as a business, it's fantastic. It's why we're all here. It's what we're trying to develop for. But consumers, you don't see that. A lot of people pick up an item, they don't know how it's printed, they often don't care how it's printed. But I think it's sometimes useful to see where inkjet can do something different based on it wasn't possible with analog. But first of all, a couple of slides on Sun Chemical. We are the world's leading producer of inks, coatings and pigments. So we sell pigments into not just printing areas, but also cosmetics and the car industry, and dispersions into the world of print, of course. But we're very much well known for our world of printing inks into the also very much sizable is in inkjet. So a couple of bit of information on our inkjet capability. Inkjet's been around for a long time, and we've been part of it much since the inception. We've been doing UV for 25 years, water-based for sort of 5 years, and very much partnered the OEM approach of wide format graphics 20 odd years ago, but then continue to develop and always developing for the new applications, while building on the success of the legacy businesses, putting that back into R&D and developing for future applications. Obviously, packaging is very strategic for us. We're very big in the analog world of packaging. A lot of R&D into the inkjet world of packaging as well. Acquired Sensient, but still the fundamental principles of our business is about technology partnership. It's working with technology people to really push what inkjet can do, and working with OEMs and new integrators is really the key to that strategy. So we're very much a global business. Very few parts of Sun operate globally. They tend to be quite regionally supported, but because of the technology nature of inkjet and the fact that it's constantly evolving, we have our main R&D centre is in the UK, in Midsummer Norton, where I work out from. But as it's expanded globally, we also have other locations, mostly for manufacture, but there is some other R&D capability around the globe as well. And it's important as inkjet grows to be able to support those customers. Transporting inks around the world is not good for the environment, it's not good for tariffs, not good for costs. So being able to make the same inks in different locations and supply them as OEMs start to sell more and more machines into a global footprint. So we are probably one of the largest suppliers of inkjet chemistry. We do make thousands and thousands of tons of inkjet every year. And we have one of the widest range of inkjets. We're not just focused on certain areas. We've got UV chemistry capabilities, solvent, aqueous, also hot melt, and some more exotic things like conducting silvers, etc. So we've got a pretty good basket of tools to develop things for the future and to keep expanding that. As I mentioned, we could have spoken about any of the subjects in depth, but given the title of Digital Print for Manufacturing and 15 minutes, just want to focus on a few things where it's probably not so strategic, but perhaps a little more interesting for the audience. But we do have business in textiles and decor and industrial and narrow web and labels, and pretty much everywhere you see inkjet, you can find a solution from Sun Chemical. So the first little case study, this isn't new. You may have seen similar things before, but it does highlight where inkjet can do something different, not just to replace what we're trying to do with wallpaper, it's to try to create a new market. If you think back 10 or 15 or more years ago, or even and beyond, wallpaper was really gaudy floral prints repeating every maybe 50 or 60 centimetres, so it was just a carnage splodge of things all over the wall, and it's quite a busy print. And then a digital project started to emerge. And it wasn't to be challenged to do the same thing as what the gravure process was, because Inkjet can't do metallics and pearlescence and flocks, but it can do long print lengths. It can print CMYK consistently, complying with the short-run capabilities, and create some bigger pieces of print. That opens a new market. You can have murals on your wall now. So there's a printer installed, it's not the latest technology, but certainly running CMYK, T-Tech heads. It's the right width for a roll of wallpaper. It gets the nice image quality, and with the software and the capability of Inkjet to have long images, you can print really nice murals. So it's complementary to the traditional gravure process. It isn't a replacement. We're not trying to do the same here. It is a completely separate business, a completely separate product line. So it's all about the short-run capability, yes, because these things aren't going to be sold in huge numbers, but collectively the volume is quite large. It was over a couple of million square meters a couple of years ago. But being able to build on that as a process, and being able to have a very capable inkjet printer that can continually change designs, print large designs, it creates something new and different. So these weren't around before Inkjet. So it's a nice case study to demonstrate something different that can be created with some applied logic and applied thought process into creating a new market. But it's not just a technology sell, it's about creating that market and creating the humdrum to build it up, so you've got a completely new scope of what you can offer to customers. The second case study is similar in some ways, but quite different. It's very new. This is something that's just sort of coming through at the moment. So this is printing onto primed coils of steel. So here it's more modern, it's wider, it's faster, it's higher resolution, and it works with other coatings to develop something that's suitable for indoor and outdoor use. So, but where would you use these things? What do you want bits of printed steel for? So it can go into garage doors, outside places, it can go on building sidings and facades, you can use it interior, exterior, so it's quite a decorative process. Also, you can do things like household appliances. You could have big fridges that aren't just stainless steel boxes or white boxes. You can make them look like a wood panel or something a bit more designer-like, if that floats your boat. And also vending machines for outdoor use. I mean, looking at the research of this, and there's a lot of metal vending machines. Some of those are quite interesting in their application, and I don't mean those ones in Japan. What I'm referring to is, you can have, I saw a case study where most modern cities you can rent e-scooters and bikes these days, but you turn up and you haven't got a helmet on. So there's vending machines dispensing helmets for return, and you borrow a helmet when you borrow the bicycle. But these need to be outside, need to be durable, they need to be eye-catching and visible, so you know where to find these things. So there's a lot of things you can add to those markets. So how would you do this, and why would you want to do it? I mean, printing on metal isn't easy, and printing on large metal historically was almost impossible. Sun Chemical in this analog world has got a sizable business in metal decoration. That's confined to printing on smaller items, so 2-piece beverage cans or 3-piece cans, slightly larger cans again, but they are confined by mostly the size of a printing plate, so repeat length is no longer than this. Printing large-scale metal panels has been difficult to the point it wasn't really ever decorated. And I think I know that because Sun Chemical uses a metal on coil. So this coil is relatively new. Previously, they were able to apply monocolours. This is why you see horrible grey warehouse boxes on the horizon, and they're a bit of an eyesore, or a green one or a blue one. Sorry, IKEA. But they're just prominent big square boxes, not really appealing. Designers are struggling to do something a bit more interesting with it. I mean, certainly Morrison's have got some mono panels and made it look a bit mosaic-like, and it's a little better, but it's still not a printed design. There are a few exceptions where you can print gravure on it, but it's pretty poor. It's often just 2 colours to look a bit like wood, like a base layer yellow with some sort of striations of brown in it, so it looks a little bit like wood within. But it's not really a high-quality image that you would see. I mean, some of the images that are coming out make it look like stone or grass, whatever. You can even go make it like a whole forest scene and make it look completely disappear into the surroundings. So there's a lot of things that you could do. This may start to appear. Now the capability is emerging. There's only a couple of these lines gone in, But certainly, you've got all the benefits of digital, your short run capability, etc. But it's about creating a new market. So how is it made? I mean, it's not a standalone printer. It is a production line. They unwind these enormous reels of steel or aluminium. Then they would prime them with a conventional coating, apply your inkjet, which in this case is UV, but it's high performance pigments, high light fastness, and in combination with the protective top coats, they can be outside for, I think, 20, 25 years they're testing to at the moment. So it's an end-to-end solution where you have unprinted steel or aluminium and then rewound at the end, and then they'll go on for further finishing going forwards. So it's a really nice solution of something that previously wasn't possible. It may not affect our lives as consumers, but I think visually we may start to see some more exotic boxes of steel on the horizon at some point, and certainly the designers have a capability now to do that with the adoption of inkjet into a previously unprintable product. So inkjet is a technology. It's got many advantages, but most of it is confined to the sort of operational flexibility within production environments. So we don't see it as consumers. The product's the same. Any savings in efficiency or cost tend to be absorbed by the big printing companies or brand owners that are adopting the print technology. So most of it is replacement technology, and consumers don't care. But the two advantages of inkjet that really make these kind of solutions stand out as being, oh, we couldn't do that before. It's the non-contact approach. Inkjet isn't a press, although they're called inkjet presses for some bizarre reason, but they don't actually touch the substrate, so you can print onto difficult items to print onto. I mean, printing on steel is difficult. It's metal, gravure, make it work. So having a difficult substrate or a funny shape, it could be a little too textured, or it could be an actual 3D shape as well. So inkjet can do lots of non-contact beneficial processes. And then the very long pattern repeat length. I mean, here the limitation tends to be software and file size and moving that data around within the system. But in theory, you could almost print as long as you wanted. It typically gets confined to being sort of 6, 7, 8 meters sometimes in length, but big enough to do a large piece. So it's a bit like the wallpaper, but also on steel, you could do something, you could put all the pieces back together and construct a mural, but rather than being the size of this wall, it's the many hundred meters long, and it's a very interesting, now decorated box you have for your warehouse or something. But it's about also combining the chemistry. Inkjet is a great tool, the engineering capability is great, but you need the chemistry to work to unlock these things. So the ink has to work not only in the print system, but also with the end product in mind. And for these industrial applications, certainly performance and light fastness and weathering all has to be taken in consideration because of the outside effect. But we're here for one reason. Inkjet's a great and versatile tool, and certainly it will continue to evolve. So I just want to demonstrate a couple of interesting applications of inkjet, even though they're not particularly strategic, but it just highlights the potential of what inkjet can do, to do something different, to do something better, and to do something new.
Thank you very much.